This video will review what we did in class today. We're in section 6, how are values of circuit variables measured. Up to this point we've done qualitative analysis of circuits. Today we're going to start measuring things and working with numbers. Section 6.1, what does a voltmeter do? So in this section we want to find out what is actually measured by a multimeter if it's connected as a voltmeter. The first step is to color code each of these circuits. It's the same circuit but with a voltmeter attached in a different place. So pause the video and do your color coding. The color coding should look like this. We should have anything connected to the positive terminal of the battery is high pressure and should be colored red. This wire coming from the voltmeter is also colored red because it's touching this wire. And a wire has no resistance in our model, so it's going to be at the same pressure as anything it's connected to. This wire is low pressure and the wire in between is normal pressure. What would we expect these pressure differences to be if we were to put our voltmeter in these different locations? Well, here we would expect a high value because the pressure difference of this wire to this wire is a high pressure difference, big pressure difference. The pressure difference here is the same, red to blue. So we would expect the voltmeter to have the same reading in these two locations. Here, if we connect the voltmeter, we see that this wire is attached to high pressure and this one is attached to a normal pressure. So this we would expect a lower reading because this is a smaller pressure difference than this. This is a bigger pressure difference, this is a smaller pressure difference. So the idea is that a voltmeter maybe measures pressure difference and we want to make predictions about the pressure differences and then make the measurements and see if it corresponds. Is it really measuring pressure difference? Here we would expect the same pressure difference as here because red to yellow is the same pressure difference as yellow to blue. So the next part, how to set up a multimeter to beat a voltmeter. This is a multimeter, and to set it up to be a voltmeter, take the dial and turn it to DCV. That stands for direct current voltage. We're going to set it at 20 because we're going to, in our circuit, have two D cells, which is 1.5 volts plus 1.5 volts. That's 3 volts. So on your dial, you need to make sure this is more than the maximum that you might measure. Okay, that will protect the meter. So 20 is the next highest above the value of 3 for our options here. Then we need to plug in the leads to the multimeter, and you're going to have a black lead and a red lead. The black lead goes in here, COM, that's the common. Black lead will always go into that spot. And the red lead goes in here where you see V. V is for voltage or volts, so that's where the red one goes in. Once you're ready, double check DC volts, V for volts, and then you can turn on your meter. Okay, so it's ready to make measurements. Here is the circuit that we had in our diagram. It is set up. We have two long bulbs in series, and we want to measure this pressure difference. We want to measure the pressure difference around this pair of bulbs. So in order to do that, we take our meter. It's a little cramped here because I want to make sure you can see everything. Take our meter, set to measure voltage or pressure difference, and we're going to connect it before the first bulb and after the second bulb. And so we take this and connect this before the first bulb and this after the second bulb. Just touch it on there and we get a reading of 2.81. Now if I reverse these and put this one after and this one before, the black one, you get a negative value. So the negative just means that you have the leads attached in an opposite way. You'll get a positive value if the red lead is attached to the higher pressure location. So this is higher pressure, this is lower pressure, and we get 2.79 now. A little measurement uncertainty there, 2.8. So our voltage for this location was 2.8 volts. And then you can go ahead and make the measurements for the rest of those circuits. Now let's talk about how to color code this next diagram. In this diagram we have two different bulbs connected in series, so this is going to be a little bit different. So we know the battery is always high pressure, so all the wires connected to the positive terminal of the battery will be high pressure, including these that are going to be connected to the voltmeter, which will make some measurements there. And the battery, low pressure, anything connected to the battery wires are all going to be at that same low pressure. But now the question is, what is going to be the color of this wire here? What pressure difference do we have here and here? Here's how to think that through. This is a series circuit, and we've learned from our using the compass that we have the same flow rate everywhere in a series circuit. So the flow rate through this bulb is the same as the flow rate through this bulb. But these bulbs have different resistance. The long bulb has a high resistance, and the round bulb has a low resistance. If you're going to get the same flow through a high resistance bulb and a low resistance bulb, you can't have the same pressure, right? If you think about blowing through a straw, if you're going to blow through a short coffee stirrer, that's low resistance compared to 4 coffee stirrers connected together in series. So the amount of pressure that would cause a certain flow through low resistance would not cause the same flow through high resistance. If you want the same flow through 1 coffee stirrer and 4 coffee stirrers, you need different amounts of pressure. You'd have to blow through the 4 stirrer sequence in order to get the same flow that you would just by gently exhaling through 1 coffee stirrer. So for high resistance, you're going to need a larger pressure difference. And through low resistance, you're going to need a smaller pressure difference in order to create the same flow rate. Okay, so the key here is that the flow rate is the same, but the resistances are different. So in order to get the same flow rate as a result, we're going to have a higher pressure difference here because this has more resistance. It's harder for the charge to get through. So if we think about our color coding, if we need a high pressure difference here and a small pressure difference here, that middle wire is going to need to be green. Now we're ready to set up the circuit and make a measurement. Okay, here's the circuit. We see that the long bulb is on, the other bulb is not, but that's just because the flow rate is too small to make it light. I think you saw that in last week's homework. And I'm going to quickly make a couple of the measurements here. So this is my voltmeter, and I'm going to measure this voltage here. I'm going to measure the pressure difference across the long bulb. So to do that, I take these 2 leads and I connect them on either side of the long bulb. And I have a reading of 2.76. So I'm going to record that here, 2.76 volts. And now I want the pressure difference across the round bulb. So I attach these leads on either side of the round bulb, and I get 0.08, 0.09. And I'm going to also measure the pressure difference across the battery. So here's my battery. And that is 2.90. So from these measurements, you can see a little bit of a pattern here, that in series, the individual pressure differences across the components of the circuit add up to equal the total pressure difference of the battery. So we could write that as the total pressure difference, that's always going to be measured at your battery, equals the pressure difference across the long bulb plus the pressure difference across the round bulb. Not exact here, right? This comes out to 2.84 versus 2.9, but it's the measurement uncertainties that are causing that, and then the wires are probably not ideally a 0 resistance. Okay, you can also make this measurement, but I wanted you to see here that the pressure differences add up, right? Red to green plus green to blue is going to be a pressure difference of red to blue. You can make similar measurements for the parallel circuit. Go ahead and color code your parallel circuit. Here's the parallel circuit color coded. And you can tell just from looking at the diagram that we would expect to have the same pressure difference across each bulb and across the battery, and you could make the measurements and confirm that that is indeed what happens. And here we could say that the total equals the pressure difference across the first long bulb equals the pressure difference across the second long bulb. Scientists use the word voltage for pressure, and so pressure difference would be change in voltage, but a lot of times we just call it voltage even though it's a difference or a change. So we can call this voltage, and the unit for voltage is volts.